Okay, next one, example 9. Okay, by using the graph in figure beside, write the simple harmonic equation. Okay, so we need to write down the equation. Okay, so kita dibagi graph ni di sini, di mana kita ada X, okay, displacement in meter against the time in second. Okay, so in order to write down the equation, kita keluarkan equation yang original, which is X sama dengan A sin omega t. Okay, so this one is only for when t sama dengan kosong, x pun sama dengan kosong. Maksudnya graf dia akan start daripada kosong, start daripada sini. Okay, tetapi graf yang kita ada sekarang ni dia start daripada bawah. Okay, dia start daripada value negative 7. So kalau dia start daripada a certain value, meaning that kita akan ada phase angle. Okay, we will have a phase angle here. Okay, so what we need to include in the equation adalah value untuk A, value untuk omega dan value untuk the phase angle. So value untuk A adalah 7, this one, the maximum value. Okay, masukkan X, which is 7, and then sin, and then value untuk omega. So we need to include the value for omega. So daripada graph ni kita boleh dapat value for t. We can get the value for period, di mana one complete cycle. So start daripada sini and then dia kembali ke tempat yang sama. Kat sini adalah one complete cycle, meaning that 4 second is the value for period. So we can get, we can find the value for omega, which is 2 pi over t. So 2 pi over 4, and then we will get pi over 2 radian per second. So pi over 2 masukkan dekat dalam ni, pi over 2, and then t, and then this one. Okay, this one, since dia start daripada sini kan, dia adalah half sebenarnya. So dia akan start daripada pi over 2. The angle here actually pi over 2. So macam mana tahu dia positif atau negatif? So tengoklah dekat bawah ni dia negatif kan, meaning that here pun negatif. Okay, so that's the equation. Okay, now let's look at example 10. A 2 kg body oscillate in simple harmonic motion if its kinetic energy K changes with displacement x as shown in figure. Find the amplitude, the period, and the maximum acceleration. Okay, so we are given the figure here, di mana kinetic energy against displacement. So value K against displacement. Okay, so what we can get from the graph here is the value for amplitude. So value for amplitude you need to know is the maximum value. So this is the maximum value actually. So from here we can say that amplitude is equal to 0.2 meter. Okay, 0.2 meter. This is the value for amplitude. Okay, next one we want to find the period. Okay, so we want to find the value for t. Okay, so daripada graph ni, selain kita dapat value untuk amplitude, kita boleh dapat value untuk kinetic energy. So this is the value for the kinetic energy. So here we can get the kinetic energy is equal to 2 joule. Okay, so in order to find T, we need to find the value for omega. So omega we can get it from the kinetic energy. Sebab kita tahu kinetic energy, formula dia adalah sama dengan 1 over 2 m omega square, a square minus x square. Okay, di mana x dekat sini adalah kosong. Sebab dekat point ni, x adalah kosong kan? This one, this point here, x is equal to 0. So x is equal to 0, and then you get, you just substitute 1 over 2, mass is 2 kg, omega is what we want, and then amplitude 0.2 square. So boleh dapat omega sama dengan 7.07 radian per second. Okay, you need to be careful here. The value for amplitude must be in SI unit. Okay, kalau contohnya dekat sini dia bagi centimeter, then you have to convert to meter, because the value for kinetic energy here, okay, kinetic energy here is in SI unit, in joule. That's why kamu kena masukkan semua value ni adalah in SI unit. Okay, so now that we have value for omega, we can get the value for period. Okay, di mana T is equal to 2 pi divided by omega. So substitute, dan kamu akan dapat it is equal to 0.89 second. Okay, so last one, what is the maximum acceleration? So we want to find A maximum. So keluarkanlah formula A maximum adalah sama dengan A omega square. So you just masukkan value for A, which is 0.2, omega 7.07 square, and then you will get 10 meter per second squared.